Kia ora, welcome to Bus Stairs. Plum tree behind me is a pretty good indicator that we're coming into spring, so the place is starting to wake up again, including me. And I'm going to do some work on my power board. So here's the main componentry I'm going to need to fit onto this power board. A ton of breakers for controlling the power to the loads, a few more for controlling the solar panels, a main control switch, the battery protect, which will turn off all my DC loads, my DSSR 20s, these little babies. Perhaps the coolest solar charging setup I have ever seen. They turn off and on my panels to charge the battery, a couple of shunts and a heap of bus bars. So let's see how it's all going to be laid out. And of course I'll need some wire and some mounts and a whole ton of other little bits and pieces, but that's pretty much the main componentry. Now, like most things I'm building for this bus, I go through a period of not really sure what I want to do, then not really sure how I'm going to do it, and then just kind of not confident that if I actually do it like this it'll be right. And eventually I get to a point of saying, well, you know what, I'm just actually going to do it like this. Now I know it all works because as you will have seen in some of my earlier videos, if you've watched my other videos, I've done this before. I've hooked these components together and I know how I want them to work. It's just laying them out in a permanent, usable, pretty fashion. So I'm going to put them like this. So I got myself a fancy easel. Is it called an easel? To do my artwork on, and I've pretty much drawn up the approximate layout of the board. So that's kind of how the design's going to go. So I guess it all starts with the solar panels, and they basically come into here, positive and negative into here. Now, this allows me to totally disconnect the panels, both the positive and the negative, using these 2-pole breakers. So that's a 20 amp breaker, and it's going to switch off both the positive and the negative if it ever should reach 20 amps. Or of course it means I can manually turn them off and disconnect them. You'll see these in one of my AliExpress haul videos. Now from there they will be connected to my DSSR 20s, which means that I need positive and negative, positive and negative, positive and negative, and positive and negative. And these will actually be doing the work. So the Electrodacus SBMS 0 controls these, turns them on and off in order to manage the charging of my battery. From there, the positive simply goes to the positive bus bar, and the negative will go to the negative bus bar. And that's my charge circuit complete. I now will have the ability to put positive into the positive bus bar and negative into the negative bus bar, which is of course connected to my charge shunt. Now that's the shunt that's specifically measuring the charge coming into the battery, and it doesn't see any load whatsoever, and it looks a lot like that. Now that is connected to the positive bus, so this is the load bus really, and that in turn is connected to the main shunt, very similar to my charge shunt, which goes to the positive battery. And the negative bus goes straight to the negative battery. In fact, it doesn't go direct to the battery, it's going to my catastrophe fuse. Now on the positive bus side, the load side, that will connect to a couple of things. Now I want a couple of unswitched circuits that are not controlled by the Victron Battery Protect. Now the reason I want that is because I want them to go direct to my inverters, possibly to other devices like that, which I can switch them off using the electrodecus. So I want a fairly chunky thing going out to my main inverter. And then the rest of that power is coming into the Victron. And the Victron turns it on and off, and I shouldn't just call it a Victron, the Battery Protect. The Battery Protect turns the loads on and off. It actually can do it on its own based on voltage, but I'm not going to use that functionality. I'm simply going to control it by remote from the electrodecus SBMS0. And so then that has power coming out to the switched bus. Now I call this a switched bus because obviously it's controlled by the Battery Protect. So when the Battery Protect, so when the electrodecus says turn everything off, switches this off, which switches off all those circuits. It doesn't, however, switch off these circuits here. These are unswitched. So all of these are connected up to the bus bar, and they go out to my loads. Simple, really? So that's pretty much it here. Now, one of my dilemmas was how to hook up 10 breakers to a bus bar without having to make up 10 little cables. And I came up with this cool bus bar idea. So that literally slots in to my breakers, and when they tighten down, then I have connected all 10 together to a single switched positive bus bar. Pretty cool, huh? So having laid it out, it does seem kind of simple. It's a wonder why it's taken me so long to get to this point. These bus bars are actually sitting up on these mounts. Another excellent little AliExpress purchase. In fact, I'll have links to as much of this gear as I can down in the description. Now, one of the things that's been holding me up with the connections is I've been waiting for these. These are little kind of ferrules. I ordered them a couple of months ago. They've taken a while to arrive. I've got them in all different sizes. This one fits a 10mm, so it slips onto here, like so. There's this little hexagonal crimper to crimp it up, and it ends up looking like this. Now that gives me something that I can stick into here and screw up tight and unscrew and screw it up tight again, and not be too worried about breaking individual strands of wire because they're captured in kind of stronger. Now I guess if you didn't have the fancy crimper, you could probably just slip it on and do it up tight, and it would still hold everything in place. So they were actually my last excuse for why I couldn't put this all together. Alright, so that's all my holes drilled. Better start mounting this gear on, I guess. First up, the Battery Protect. Now let's chuck on some rails to mount the breakers on. So, because I can't actually screw into this acrylic sheet, it's a bit too brittle for that, I've drilled holes through it, and I'm using these little M3 nuts and bolts. And so next up is my DSSR 20s. Aren't these such a nice looking unit? They're actually in pieces, so you can actually see all the circuit board here, beautifully laid out, nicely done. On top of that goes a spacer, and on top of that goes the cover. Oh, nice little setup. Right, so that's my random selection of mounting hardware. DSR 20s in the middle. Let's throw the bus bars in. Here's an important little tip when you're putting heat shrink on. I put a little bit too much on this one, so I've cut it away at the top for the washer to sit nice and flat. Not as critical, however, as the back, where this needs to come into contact with the thing you're bolting it onto. So it's important that there's no heat shrink on that face holding it off and causing a poor connection, so that when it's actually on, it's fully touching the copper bus bar. Alright, so that's looking pretty good now. I've got my shunts installed, and yes, that third shunt is not required. I mean, this one here, I just like the way it looks like a flux capacitor. And this is how my bus bar works, fitting directly into my breakers. So that gives me 10 breakers. That are switched by the battery protect, and 2 that are not, which I haven't yet wired up, but they'll go through probably through that hole there. Now I polished up my bus bars, as you might be able to tell. So I have my solar isolators, and breakers, 20 amp breakers, coming through to the DSSR 20s, and then through to the charge bus bar and the earth. Now the earth will have the main earth coming into here, and the main positive will come into here. So I'm thinking I'll put some physical barriers from this Perspex offcuts off to separate the positive and negative, and maybe a couple more around and one across the top, just so that I can't drop anything onto it. But yeah, it's come together quite nice. Now for the cabling, I did end up using my leftover solar cable, so that's 10mm squared, which is ample really for the job it's doing. It's a little bit of an overkill. It looks quite nice, and I've got it in black and red, so it's clearly defined what's what. It's a little harder to bend than welding cable, but once it is bent, it stays nice and bent. So I'm pretty happy with that. So I think I will just glue some more of these dividers into place, and then I'm just about ready to slot it into the bus. I don't have the control circuitry installed on here. That will actually go behind this panel. So whilst you might see a little bit of it, it'll be mostly hidden. Out of each one of these DSSRs will be 2 wires that will come down and go out through that hole. That's the remote for the DSSR 20s, and this remote cable will come out and go out through that hole there, along with the earth, which needs to come back up through this hole here and be attached behind this bolt. And of course these bus bars are actually the old battery links from my previous battery, and likewise of this one here, and this one here. You can't really see the holes in the background, but they are there. Right, so this is just about ready to go into the bus. I'm just going to put a few finishing touches on it. What I want to do is to build some little barriers like this, just to separate the different parts of the board. So I'll have this across here, keeping the positive side away from what will basically be the negative cables coming out. I've already put this piece in here, and the cables actually pass through it, so it kind of adds a certain amount of support to the cables themselves. This piece here, I've bent this just to make it fit in nicely, and that'll keep the switched and fused cables away from the incoming solar cables. Now in doing so, I've bent this piece with just using a heat gun. So what I might do is just show you how I went about that, because that looks pretty cool, and it was really easy. And I want to bend a couple more pieces up. So I've got a bit here ready to bend now. Now I'm simply going to bend it over the end of this piece of wood. I'm not too worried about the corner being particularly fancy or a specific radius or anything like that. I've marked just with a little dot where I want the bend to be and simply clamped it on here. Now this piece here is just hanging there. It means that it can use its own weight to do the bending, and I'll know exactly when I've got the temperature right. Now the process is really straightforward. I just need to heat the plastic up until it goes soft and bends. Now the only thing I've really got to watch out for is I don't heat it too much, or it'll melt and become maybe burnt or damaged. So I just crank the little heat gun up and really just wave it over it. And I need to do both sides to make sure that it is heated right through. Now once I hit the right temperature, it's going to start to sag. So with a kind of complex bend like this, it's just a case of getting it close and then tweaking it once it's soft. And this is close enough for my particular needs. But for this piece here, I want a right angle bend, so I'm simply going to bend it until it's straight up and down. And that's it, piece of cake. In YouTube time, seconds are hours, so of course I don't show you the whole thing, but it's literally less than 60 seconds from clamping it down to finished. Trim the edge off with a jigsaw and I'm done. So what this does is it isolates the positive end, gives me plenty of room for my connections, which I think will come in at about this level and go up, and plenty of room for the negative connection to come in and go down. That's my main connections from the battery. Once it's mounted on the wall, this top piece will reduce any risk of dropping anything on top of it, and then the last piece to go in will be here, and I think that'll segment it up fairly nicely. So my next problem now is I need to find something to glue these on. Now none of the glues I've got will stick to this at all. I guess if I sanded it back and gave myself a rough surface I might be alright. But I might need some sort of cement that eats into the plastic. My trusty Sikaflex 11FC does not stick to it at all. In fact, nothing does. I've even tried gluing some sheets together and I can literally peel them apart, which is not good. So I have to come up with something like that, and then it's ready to go into the bus. So thanks for watching this video. Next time you see this, I'll be mounting it in the bus and hooking it up to the solar panels and to the battery. And hopefully by then I will have solved the problem of how the hell to stick a piece of this to another piece of this. But in any case, that's for another time. So I hope you enjoyed this video, and if you did, hit the like, maybe the subscribe, hit all the buttons, and hopefully that means we'll see you again soon. Take care, mā te wā.